Good morning, student. I am going to teach you about the course Computer Communication. Myself, Dr. A. Samuda, working as Assistant Professor in the Department of Computational Intelligence. My research interest is deep learning, data science, machine learning, artificial intelligence, IoT, and data analytics. In second unit, I am going to give an introduction about IPv4 addressing, address space, and IPv4 address notation, classful addressing. In the internet, we can connect millions or billions of devices in a network. In order to identify a device in a network, we used IP address, Internet Protocol address. IPv4 address is a 32-bit address, which is used to uniquely, universally define the connection of a device. The device may be any system or router. Since the size of IPv4 address is a 32-bit, so the number of address space required in this is 2 power 32. It is unique and universe. Why it is called unique is the device on the internet can never have the same IP address. In order to identify the individuality, we assigned a unique IP address. And universe means in the network, the address system must be accepted by any host within the internet. So we can represent the IP addresses in two different types of notation, in binary notation and dotted decimal notation. In binary notation, the total size is 32 bits, which is divided into 4 bytes. The space is separated by dot. In dotted decimal notation, 4-number decimal representation separated by the dot symbol. So this is a binary representation of IPv4 address. 128.11.3.31 is a decimal representation of IPv4 address. When you take any IP address, it is a combination of a network part and the host part. So the network part is assigned by the global authority, by the organization, whereas the host part is assigned by the local authority of the organization. We can change the IP address from one notation to another one notation. In the coming slide, I will brief about that. So now consider the problem. Change the following IPv4 addresses from binary notation to dotted decimal notation. So first take the problem. First problem, here the given a number is written here. It is a 4 bytes of data. Consider the first byte. So in this first byte, the particular decimal, here I applied 8421 code. So the particular decimal values are added. So here the 128 bit is enabled and the last bit 1 is enabled. So 128 plus 1 equal to 129. Similarly, if you consider the second byte, it is having the value 401011. If you applied 8421 code, so it is a summation of 8 plus 2 plus 1. Finally, you will get 11. So the third byte also the same data, so that you will get 11. Consider the fourth byte of data, the 111041. So this is nothing but 128. This is nothing but 64-bit. This is a 32-bit. This is a 16-bit is 0. So remaining 8, 4, 2, 1. So this all the enabled bits are summarized. So finally, you will get the value 239. So for the given binary notation, the corresponding decimal representation is 129.11.11.239. Similarly, you can change the following IP address from dotted decimal notation to binary notation. Consider the first byte 111. If you divide that value by 2, you will get the reminder like this. You have to write the binary representation starting from bottom to top. So it is nothing but 0, 110 and 111. Similarly, the second byte of data is also calculated. You will get 111 and 000. The third byte of data 45 also divided by 2. You will get the answer 101101. Similarly, fourth byte of data also calculated, which is nothing but 1001110. So finally, if you summed all the 4 parts, you will get the corresponding binary representation. So this is the way you can change the given IP address from one notation to another one notation. In some cases, instead of IP address, we can represent the system using domain name system. Domain name system, example, www.google.com. So this is a domain name system. So the Google is a server name, World Wide Web Consortium. Okay, and the .com is represent us. It's used for commercial purpose. So the IP address identifies the interface which is capable of sending and receiving the IP datagram packet. So each host is having only one interface, whereas a router in a network is having multiple interfaces. The IP v4 address is having a header structure like this. So the 32 bits data are divided into several parts: version, header length, types of service, total length, identification, etc. So the version indicates the version of IP v4 address. The internet header length, 4 bits length. It indicates the number of blocks represented in the IPv4. And the type of service indicates the desired service expected by the packet before delivery. The total length indicates the length of the IPv4 packet, whereas the identification indicates this packet identifies the IPv4 packet or not. So if this field is selected by the source, means it is fragmented. All the fragmented data are reassembled in the destination side. The flags, 3 bits, it identifies the flags for the fragmentation process. If the flag value is 1, means to indicate whether the IPv4 packet might be fragmented. And another value to indicate whether more fragments are required or not. Then the fragment offset 13 bits, it indicates the position of the fragment relative to the original IPv4 data. And the time to leave indicates the maximum number of links on which IPv4 packet can travel before discarding the data packet. And the protocol, 8 bits, it identifies the upper layer protocol. Header checksum, 16-bit data, it provides the checksum of the IPv4 header only. And also it has 32-bit source address and destination address and optional field also. We can classify the IP addressing into 2 types, classful and classless addressing. Consider the classful address. It is divided into 5 categories. According to the net ID, host ID, it can be classified. So class A address is taking the large number of host or router